Hello, Honors Algebra students. Mr. Lawrence here, and this is your video for Tuesday night. It's on working with sets. Okay, and what we're going to do is we're going to be expressing sets in different forms. One form will be roster notation, so we definitely want to take notes here. Roster notation is a form of a set notation that lists. This is going to be terrible. You're not going to be able to read my chicken scratch, especially writing with that pen. So let me do it this way. Okay, let's go. Roster notation lists all elements of the set, which means all elements is all members. Okay, all the members of the set. And I'll give you an example of that here in a minute. I'm going to give you these definitions first. So it lists all the elements of the set. Okay, now, excuse me. Set builder notation is different because it doesn't list all the members. In fact, when you use set builder notation, you can't list all the members. It's not possible. It's kind of like if I said, write in roster notation all the natural numbers. You can't do it, okay? So set builder notation would be more effective with that. And set builder describes all the elements or members of the set. And so let me show you how to use this, okay? So we've got this statement here. T is the set of natural numbers that are less than 6. Okay, natural numbers, they start with 1 and they go on forever, right? We've studied that. Okay, well, let's do roster notation. Roster notation is simply going to be T, YT, because that's the name of the set, and that's going to equal the set, and you make these little braces, and no, you can't just do a parenthesis, and you can't do this. Okay, it has to be this brace, and I know it's a coordination thing where you might not be very good at it, but you practice. I kind of think about it as kind of a person's face. I mean, I do this little forehead thing, and then the nose juts out, and then pops back, and then there's the chin. Okay? And now since it's roster notation, I'm just going to list the members. Well, the natural numbers begin with 1, and 2, 3, 4, and then 5, and then I close my set with another brace just like that. And if you practice, you will be able to do it, but you can't make up your own version of that. Okay? It's got to be that symbol. Different symbols mean different things in math, and that's one of the cases. All right, now to do it in set builder notation, it's a little bit different because I'm just going to describe the elements. So in set builder notation, it's going to look like this. It's going to be T, and that's going to equal the set of, and I'm going to write a variable here, and I'm not going to use T because it'll get confusing. I'm going to put X. Okay, and I'm going to draw this bar here like this. And then I'm going to describe it. Describe the conditions. X is a, what kind of number? A natural number. Natural number. Okay. I put a comma, and then I'm going to put the inequality. X is less than 6. Now I'm going to interpret this here for you. All right. So first of all, the way we read this is T is the set of all real numbers, x, such that x is a natural number where x is less than 6. So this is all real numbers x. Now I could use a different variable there. Like I said, I don't want to use t because it gets confusing, but I could have put an a or a b or something like that. But x is very common. Okay, this is read as such that. So what I'm starting with is that x is any real number. And now this such that means I'm going to narrow down the real numbers. I'm not going to use all real numbers, okay? I'm going to say that x has to be a natural number. This is read as where, or you could say and then you read x is less than 6. Okay, and where did I get that? From the story. So let's look at another one here. And I want you to pause the video and try to do it on your own. So go ahead and pause the video. Okay, by now you should have given it an attempt on your own. let's see, it says that Q is the set of even whole numbers that are less than or equal to 12. So let's go roster notation. Remember, roster notation, you just simply list out the members of the set. So in roster notation, let's see, even whole numbers. So the first even whole number would be 0, and 1 would not be even, so 2, 4, 6, 8, 10, and finally 12. Okay, there is the roster for the set Q. Now in set builder notation, okay, I'm going to go Q equals the set of all real numbers x such that, let's see here, x is an even whole number where x is less than or equal to 12. And there you go, it's set builder notation. So all we're doing is describing the set. We're starting with all real numbers, and then we're narrowing it down to even whole numbers because we were told to, and then we're stating the inequality for the boundary of these whole numbers, these even whole numbers. All right, so that's roster notation and set builder notation. Now, I want you to solve this inequality and then do your best to write the solution in set builder notation. Okay, go ahead and do that. Pause the video. All right, I'm going to solve it now, and I'm going to subtract 7 from both sides. And when I do so, I'm going to get, where'd my mouse go? Negative 5x less than or equal to 10. And I'm going to divide by negative 5. Divide by negative 5. And then x is going to be greater than or equal to negative 2. All right, so there I solved the inequality. Now we're going to go to set builder notation. And so set builder notation is going to be the set of all real numbers x such that x is greater than or equal to negative 2. Now I didn't have any extra stipulation in there like x is a natural number or an integer because it's not limited to that. These solutions are any number greater than or equal to negative 2. Like if I went to a number line, right, and I was at negative 2, the solution would look like this, yes? Okay, well, negative 1 is in the solution set, but so is negative 1.5 or negative 1.25 or pi. So all the rational and irrational numbers are included in there as well. So I didn't have to put a stipulation on it. All right, here's another one. Again, I want you to try it on your own. So go ahead and pause the video. When you're ready, look for my solution. Okay, here comes my solution. I'm going to add 6 to both sides. Wait a minute, did I have a mistake on that last problem? Hold on one second. No, I didn't. Okay, good. Hopefully you know why the inequality flipped. All right, so sorry about that. Come in here. We're going to have 2x is less than or equal to 30. Divide by 2. Divide by 2. X is going to be less than or equal to 15. Okay, so now set builder notation. I can't write this in roster notation, can I? No, because the set is infinite, right? So I have to use set builder. So I'm going to go the set of all real numbers x such that x is less than or equal to 15. And there we go. All right. Now we need to talk about subsets. And this is going to be kind of weird because at first it's going to be super easy, but then you're not going to realize certain things are subsets. And then hopefully you'll come to realize it actually is super duper easy. Subsets are all the sets that it can make from the given set. You remember those things your teachers might have you do in elementary school where they give you the word like, I don't know, plasma, and they ask you, how many different words can you make from plasma? And you go map, and then you might go lap, and then you might go maps, right? And you see how many words you can make? That's kind of what we're doing with subsets, only we don't have to actually make words. So one thing you need to understand before we can do this is the meaning of this symbol. Some of you were kind of making 0 like that, and I told you not to do it. This is called the empty set. It's the set that has no members. And it's going to sound strange, but the empty set is a subset of every set. Yeah, the empty set is a subset of every set. Did you write that down? Because I repeated it. The empty set is a subset of every set. So, if I'm going to go list all the subsets, the first thing I like to do is I like to start with the empty set. Okay, that way I don't forget it. Then I like to list all the subsets who only have one element. So for example, 0. And then of course, 1. And then 2. And finally, 3. So the subsets are miniature versions of the bigger set. Now that I've done all the subsets who have one member, I'm going to do all of them that have 2 members. And I've got to be careful here to make sure I go in some kind of order so I don't mess up. So I'm going to do 0, 1, right? And then I'm going to do 0, 2. I'm trying to be very systematic about it so that I don't miss any. 0, 3. Now there wouldn't be any other subsets that have 2 members and start with 0. So now I'll go to 1. I'll go 1, 2. The subset 1, 2. By the way, I'm doing all these subsets in roster notation, aren't I? And then I'll go 1, 3. There are no other subsets that would begin with 1. I won't do 1, 0 because that's already done here, right? That's already done. Okay, so now I'll do all the subsets that have 2 elements or 2 members that start with 2. So it'd be 2 and 3. And I think that's it for 2-member subsets. So now I'll do 3-member subsets. So I'll go 0, 1, 2, and then 0, 1, 3. Okay, and now I'll go 0, 2, 3. Right? Okay, and I don't think I can do anything else with 0 as a lead. And so I will go with 1, 2, 3. And I do believe that is all the members, all the subsets that have 3 members or 3 elements. Yeah, I believe that's it. Okay, now I'll do all the ones that have 4. And you're like, but that's the original set. Well, let me tell you, just like the empty set is a subset of every set, so is the set itself. This given set is a subset of itself. So let me get that 0, 1, 2, 3, and there we go. Now, by the way, there's a special relationship between the number of subsets and the number of elements. See if you can figure it out without asking anybody. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. I'm just counting. 9, 10, 11 subsets, 12, 13, 14, 15, 16. Now I know the special relationship of number of elements, this one had 4 elements, and the number of subsets. So I know I have done all the possible subsets. I wasn't sure of it myself. I was thinking, oh no, there must be another subset somewhere. But then when I counted, I liked the fact that there were 4 elements of the original set, the universal set, and 16 subsets. tell you what, why don't you try this one? It says find all the subsets of the set red, white, and blue. Okay, so pause the video and then you go ahead and try. Here comes the solution. So first of all, I start with the empty set. That's one subset. And I'm going to abbreviate. Whoa, what the hookah waka is that? Let me get rid of that there. Okay, so I'm going to abbreviate. I'm just going to do red. And then I'm going to do the subset blue. And then I'm going to do the subset white. And I think that'll take care of all the subsets that have only one element or one member. So now I'll do all the ones that have two. So I'll do red, blue. And then I'll do red, white. And next I will do blue, white. So now I've taken care of all the subsets that have two members or two elements. So finally, all the subsets that have three elements, and that would be red, blue, and white. It does not matter that it said red, white, and blue up there. By the way, there's that special relationship again. Have you figured it out? Maybe not. You haven't seen very many. There's three members. And look, there's 1, 2, 3, 4, 5, 6, 7, 8. Yep, I got them all. So that's subsets. All right. So last thing we're going to learn about, the complement of a set. A complement is all the members of a bigger set, a universal set, such that they are not in a subset. What the heck are you talking about, Mr. Lawrence? Well, let's let U be the universal set of natural numbers less than 12. So U, natural numbers less than 12. So U would be the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and finally 11. Oops, I don't know what that is. That doesn't look like an 11. Okay, so there is U, the universal set. It's kind of like the parent set. So now A is going to be a subset of U, and A has to be a prime number. You know what I'm going to do is I'm going to go through and I'm going to highlight all the prime numbers. So by the way, 1 is not prime. No, it is not. 2 is prime. Oh, you don't know what a prime number is? A prime number has two distinct factors, 1 and itself. And that's it. No other factors. 1's not prime because 1 only has one distinct factor, 1. 2 is prime because the only two factors of 2 are 1 and 2. 1 times 2 is 2. 3 is prime because 1 times 3 is 3 and nothing else. When you're limiting yourself to the natural numbers, can be multiplied together to get 3. 4 is not prime because it has three distinct factors. 5 is, 6 is not, 7 is, 8 is not, 9 is not, 10 is not, 11 is. So A in roster notation is the set 2, 3, 5, 7, and 11. Now, the complement of A, you write it like this, A prime, it means the complement of A are going to be all the members of U that are not a part of A. So you see all the things I highlighted in blue? Those are A, right? A prime, the complement of A will be everything I didn't highlight. So it'll be 1, 4, 6, 8, 9, and 10. So the complement of A fills out the set A to get you back to the universal set. If you put them together, you get the universal set. So the complement is all the members of the parent set, the universal set, that are not in the subset A. Okay, that's all it means. All right, so I think that's it for the video. Oh, no, wait, look, I've got one for you to do, silly Mr. Lawrence. So, you is the, would you like to say hello?
Hi.
Say something funny. Oh, he's thinking. He'll get back to us tomorrow.
Booker.
Booker, there we go. There's a funny word of the day. All right, that's my son James, by the way. So in this one, U is going to be the universal set red, yellow, blue, green, orange, purple, brown, and chartreuse. All right. A is going to be the set red, yellow, and blue. On your own, find the complement of A. All right. I'll expect you, I'm going to end the video here. I want you to show me when you come into class tomorrow the complement of A. All right. Show me the complement of A. All right. That's the video for tonight. Mr. Lawrence signing off. Have a good night, everybody.